Let's hope you can't hear us. Okay, so we'll get started. So my name is Lombrozo. I'm Shawn Radovich, and we came from Albuquerque, New Mexico. We work at San Diego National Lab at a large powered X-ray generator called the LabVIEW machine.
Can't hear you.
So,
Is this better?
yeah, you need
I just
to
got shoved
hold
in the
your
face.
face.
Okay,
Yeah.
So good?
Yep.
Okay, so anyway, so we work at this large pulse power facility, and if anybody's ever dealt with pulse power before, it gets really destructive on the hardware you use, as well as any associated electronics nearby. So we have the wonderful pleasure of fixing all this up after every experiment, and just rewiring stuff, rewriting software, just trying to get things to work again after the scientists destroyed all the equipment we worked so hard. So as we've done all this, we've come up with a lot of innovative ways to write code quicker, simpler, like get everything working quickly, especially as the scientists keep changing the requirements. So we'll go through little things that we've learned, and hopefully some of you will find it helpful. As we go through the presentation, if there's any questions, feel free to stop, shout, yell, throw things, go for it, and we'll try to address anything as it comes up.
Okay, so this is, we uploaded this last night to this website right here on NI, so if you want to get a picture of this, it's the most recent presentation, also all of our code, demonstrations, everything that we go over. So we'll give you a
Pull out your
second.
phones, take pictures.
So sorry for the long
Make sure
link,
you get one first.
we didn't want to do the bit.ly thing because that would take too long time. And then it changes sometimes, so. Okay. Everyone got it?
Still see lots of cell phones?
Okay. So we stole this tip from Darren, who always does his efficiency thing, so that way everyone can get all this up, don't have to write stuff down and worry about that. All right.
Okay, good?
So if you need it later, we can go back at the very end.
Yeah, I think we're the presentation of the day, so come up afterwards and talk, and you can take pictures, whatever.
Okay, so I guess LabVIEW is a programming language just like anything else. A lot of times you'll go to the NI Core 1, Core 2, Core 3, and you learn a very specific way of what LabVIEW has designed. And then people just stick in those boxes for the rest of their LabVIEW career. We saw those, there's a lot of things that they do that aren't really the best ways to do things, that they don't teach you everything. They just kind of want to get enough knowledge in your head. So we like to challenge that principle and use LabVIEW as it's intended to. So we're always looking for new things that we can do, new tips, new tricks. But ultimately, we just want to remember that the LabVIEW is a programming language, and we want to write things that are readable, modular, flexible, and reusable. Make things as flexible as possible. So just a quick thing, you guys probably have all heard of this, especially I know the user interface thing was just here, so they probably do much better of this. But a lot of our interfaces, we don't go into too much depth, but we do want to make sure that we use easy things for our users. So they're used to the interfaces they see, we make things consistent, they know what they're getting into right away. And that can make a huge difference, even if you don't spend a lot of time doing all the fancy tips and tricks. If you just kind of do some very easy things like the ones listed here, that adds a lot for your programs.
So here's where we start with the LabVIEW stuff. So these are some little optimizations that we've come up with. They're surprisingly helpful. They save us a lot of time in programming. So, you know, one of the nice ones is defer panel updates. If you haven't used it, it's really simple. You get a reference to the front panel and you turn it off. You update whatever you want and then you turn it on. And it will allow it to change all the things at once on the screen as opposed to one thing at a time. If you've ever tried to update 100 things on the screen and then had your user sit there as he watches little things pop up left and right, it gets kind of tedious. It gives like weird wave effects, but there's only one UI thread and it can only update one thing at a time. So by deferring this, you basically tell it, wait, I'm going to do a bunch of things, and then go. It makes it look much smoother. Another thing, whenever you're dealing with folders, create the folder first and then save a file. A lot of times when you're testing out your program, you have the folder, you made the folder, And it works out great until you deploy it to a computer that is the first time running, and then it's like, I'm having a file write error, I can't write there because it doesn't exist. Create folder, clear the error, never have to worry about that again. Whenever you're doing runtime programs, building actual executables, throwing them out there, you could spend half of your programming time just cleaning up after yourself, or you could just try and abort VI, just kill everything, see if the auto cleanup works properly. It'll get rid of all the memory for you, and if it doesn't, then find out what things it's doing and clean those up yourself before killing the program. But if it works the first time, you're done, you can deploy it, you can get on with your other projects. Finally, optimize only when necessary. Don't go into a task thinking, oh, well, the optimal way to do this is by creating a buffer and filling up that buffer one thing at a time and cycling through it programmatically. Just write your code, see if it works, and if it takes 10 milliseconds longer to run, most of the time, who cares? Your computer has 400 to 400 cores in it, and it'll just run.
Okay, so I'm not sure if you guys have used Brat Eyes, but essentially a Brat VI is a VI that you can drop into any VI, and it will change the behavior of the parent VI. So just to kind of give you an example of this, we'll jump into a quick example. It keeps changing our projector back and forth to duplicate and extend, so we'll probably jump back and forth on that for our examples. So we have a VI here, and you can see the alignment is off. So one of the Brat VIs that we created was a VI that will realign it. So this happens maybe if you're developing some code, you move it off screen, and then you build your executable, send it out to your users, and then they come to you and they're like, I can't see anything on my screen because you shifted it. So in order to fix that, we created these Brat VIs, and so there's two examples here. One of them is the align VI, the second one is a window locate VI. And you can see you just drop them on the block diagram anywhere, and then when you run the code, it's going to align them. So the align VI is going to align it up based on the origin on the front panel, and then the window placement VI aligns it to where your mouse was. And so it's a very quick way just to make sure your user interfaces work how you want them to. They're displayed in the right orientation. And all it takes is just a single VI that you just drop on the front panel. It gets a reference dynamically to the VI that's calling it, and then you don't have anything else to do with it. So those can be very, very convenient when you're doing a lot of different things. There's a lot more applications for that. These are just a couple quick and easy ones. Turn me on.
You weren't saying anything for it,
Was that? The Brat, these Brat VIs we developed. They're in the example code. You can go grab those two and see what we did. And so it's really just like property nodes. Nothing that's a big deal, but if you just look at those, you'll see how we're getting the reference to the parent VI. Those ones also have an input that if you wanted to go a couple levels deep, that you could plug in a reference to it as input. If you don't pass in the input, it'll just, hey, whatever call me and use that. So it's pretty convenient to do that. And yeah, so I'd highly recommend those just as quick and easy things to drop on your block diagram.
So the next thing we'll cover real quick, configuration files. I'm sure everybody here has written some sort of file parsing program going into the different ways of being like, well, I can pack this data here, or maybe you just need a really quick, configuration file at the beginning of your program, and of course your drop down open file, read file, parse text, all that stuff. So LabVIEW provides a basic configuration file palette that nobody seems to know about. Jump into some sample code here. That too.
Yeah, if you didn't go on the back, he said OpenG has an excellent palette that'll work with that.
So you can see up at the top, creating that folder, clearing the error, just in case. It's a very easy one to find, and because it comes with LabVIEW, it's on every LabVIEW install. So from there, you can really quickly say, I want to open the config file, I want to add text with keys and all that fun stuff. This is the file you would want to use if you want to programmatically edit the INI file that comes with LabVIEW executables whenever you build them. Whenever you have runtime things, whenever you're running real-time stuff on Compact Rio, Compact Field Point, this is the thing that they use, the format that they use. So you can use this to programmatically add things or check things from there. Other options, XML, JSON, you can toss in a cluster, pull out the same cluster, save it off the file in between, or you can just use CSV files. There's functions to parsing a CSV file right there.
We like the CSV files for a lot of our configuration because it's user readable and you just open it in Excel. So we use those a lot for configuration. Okay, so some troubleshooting tips we use. Obviously, if you're writing code, things are going to go wrong. You want to figure out where things are going, how to troubleshoot things quickly. So we've developed a few things that we use for this. One of them, every time you are dealing with queues, you have to get a reference. And so one of the things that we've done that works really well is we just put that queue reference in a functional global, which does two things for us. One, it keeps us from having a memory leak that every time you're getting that reference and you just have thousands of references to this queue laying around in your VI. The second thing is it makes it really easy to troubleshoot where you're using this queue. So if I have 5 different places, all I have to do is just do a right-click find on this functional global variable. I can see all of my producers and then find the consumer very, very quickly without troubleshooting. We really love the bookmark feature that LabVIEW put in. I think it was in 2013 when they added that. And so the bookmark manager is great for a lot of different things. Some of the ones that we use a file hashtag. And so this one works really well when we have configuration files, we're saving files, we're doing something along those lines. If you put like a hashtag file or really anything else that you want to jump to specific parts in your code, so what I'll do is put the hashtag file and the name of the file. That way if I have a problem with the configuration or all I do is pull up the bookmark manager, go to file, find the name that I'm looking for, and I can find right in the code right where that file is used and fix whatever problem it is. So it's really a quick way to jump to that stuff. To do, obviously, you've got future enhancements you're working on, or I want to do this thing later. You go ahead and type in the to-do, whatever you want to do, and that way it's a quick thing so you don't forget about all these little things you were going to do later. But the possibilities are endless. Think about what would be helpful with whatever application you're using, just as quick jump-in points to where you want to go. Custom probes are something within LabVIEW that I had no idea what they were. Tim, who's over here, gave a presentation at our local user group meeting. There's a lot of different things you can do creating custom probes. We're not going to go into any detail with them, but we created a couple. You just drop them into a LabVIEW data folder, and you can use them when you're troubleshooting. So they're pretty powerful. If you haven't used them, they're worth looking into. One of the things that we do for our end users is when we release any applications, we'll create a bunch of off-screen indicators, usually of error indicators, things like that, maybe some data that we would use for troubleshooting. And then that way when they come to us or call us up and say, hey, this thing isn't working, we can just go down there and just expand the window, and then that way we can see some very quick information that they don't need to see, but would be very helpful when you're running an application and you're like, I don't know what's wrong. And so this last one here, we shamelessly stole from a NIWeek presentation a couple years ago that we went to. And we'll give you a quick demonstration of where this helps. I don't know if any of you guys work with modal VIs, but I do it all the time. And you're running your modal VI, or you're writing your modal VI, you forget to close it in the background, and then you hit run on whatever VI you're testing, and now your whole LabVIEW thing is broken. So this is an example of this, right? So I have the stop button, and that's the only way to stop it. Great if that stop button is on the screen. But if I happen to do this, where I go, now I'm in trouble, right? My options are kill LabVIEW, start over. Hopefully I save it. What this VI does, and there's a whole bunch of other little tricks in here. The link to the presentation is on here, so you can go get all the information from them. But, so they created this VI. All you have to do is just type in the example. You can abort the VI directly from there, and you've got control back. So. And this VI will always put itself in front. So it's a very quick little tip just to help you in that scenario. I've used it a bunch of times and it saved me from having to reboot LabVIEW every time. So I highly recommend that. They've got a bunch of other little tips that are helpful, so check that out at the link we gave.
Oh, another trick, you just hit control period.
Not always.
That only works until you disable that, because you don't want the end user to do it. I've done that. So previous presentation we gave was on the stack architecture, status array clusters. So if you want, you can go check out the presentation. It gives some nice information. It's a very simple architecture that you can deploy quickly. The whole idea is that it handles everything programmatically. So let's say, in our case, we had a distributed system with 5 compact RIOs spread across the facility, and you wanted to pull all this information from numerics and booleans and whatever else, and you want to pull it all together on the server, and then have a front panel interface for somebody to interact with. So you could spend weeks writing code for each individual I/O line, map this I/O line to this indicator, this I/O line to that indicator, which takes forever. This architecture basically lets you deploy some very generic code, collect everything together, pack it into this SAC, which is just a cluster of a couple arrays, 2 strings and a timestamp. And you can programmatically pack information in based off a config file, and then programmatically update the front panel. And the only code you have to do is basically put down indicators and controls. And everything just matches up, and if somebody wants to add one more sensor, if someone wants to add one more actuator, you can give them manual feedback and basic feedback and manual control without having to write any code other than, here's an indicator, it's numeric, okay, we're good, run it. So if that's a situation that you ever find yourself in and you don't want to spend all the work of wiring up 500 different types of things, definitely look into this presentation. And if you have any questions about it or implementation, give us an email or contact info's out there, and we can guide you in the right direction.
Yeah, in some of the examples we have going forward, you'll see this is the backbone of almost everything that we do. And so it's kind of, for us, it's just, like the second, back of our hand, second nature. And so if you have questions when we pull up the code, feel free to ask us, and we'll go into more detail. But that's just kind of a quick overview of the presentation we did a couple years ago. Okay, dynamic event registration. I'm not sure, who in here has heard of the dynamic events and uses them? Okay, most of you, that's good. If you haven't, this is a great tool that just makes things really, really quick. The one caveat that we recommend is making sure that you have some sort of naming convention or something. It needs to be very consistent and well-defined. So we're just going to jump into the example. So here's a VI we were talking about. We just dropped out a bunch of controls. There's a bunch of indicators that. So if we jump back to the back end of the block diagram here, you'll see without dynamic events, you have this giant list. I want to handle everything the same way. And so I have this whole giant list of everything. And I can't tell what's what. Even we pull it in here, there's a whole list. Now I want to see which one of those controls did I accidentally leave off, and when I build it, it's not going to work. It's incredibly difficult to find. At least LabVIEW lets you expand this, the event source column there now. They didn't used to. So you can see there's 30 different things, I think, in there. It's very hard to find the one that I accidentally left out and overwrote. Dynamic events basically allows you to programmatically grab all of those buttons and add them to an event case. So same VI. The magic here is in this very beginning part where I'm just getting a list of all of the indicators on the front panel, finding out which ones are indicators, which ones are controls, and I'll just take all the controls and put them into this value change event. Now all I have to do is add this, you see the number 1 up here at the top. I just right click on my event structures, they show dynamic event terminals, those pop up, and now the code is exactly the same as what it was before, but now all I have to do is I don't have to add everything manually, it's all already there for me. If I add a new control, I don't have to add it to my event structure, it just automatically works. So if you haven't used that, check out this example. It's super powerful, and we use it for pretty much everything once we found out about it. So,
So the next thing we'll talk about is launching VI programmatically. So I'm sure lots of people, you've at some point been like, well, I want to launch this VI, but I want my code to continue, and I want to do something else, whether or not I want to get data back, the whole other thing. So I'll just jump into the code example. So first, building paths. I'm sure everybody's done this before. You got a bunch of different options out there. You can start at the end, you can start at the beginning, you can build your path one at a time, do the whole thing, or what I prefer, static VI references. So you drop one of those down, you say, I want a path, or I want a link to that VI. You can then grab the path and use that directly. So if you ever go back to your project and you're like, I'm going to change the name of that file to make it the name of the other stuff. If you did it any of the first three ways, your code would now be broken. If you did it the last way, and then you forgot about it, your code would still work. Problem solved.
Does that run back to cubicles?
It does. Which is why I do. Most of our code is compiled and deployed. So here's different ways to launch things. You got the first standard call. You just put it down and it calls it. You will have to wait for it to finish before you get the output from it. The second option, programmatic call. So like you see, static data reference, get the path, feed that into an OpenVI reference. You can now populate controls by name with that control val set invoke node. And then you can run the VI, you can open it, you can show the user, or you could not show it to the user and do something else with it. Next option is you want to do a reentry programmatic call. So let's say you want to run one VI, in this case 4 times. You can do it pretty much the same way. The key difference is that reentrant flag right there. So you have to choose the right flags. That can be confusing on itself, but if you start with code that works, you already have it running. So give it the reentrant flag, set whatever controls you want to do, run it, open it, etc. And then the last one is something I think was added relatively recently, the asynchronous call nodes. And this makes it a lot easier to get the data back from the reentrant VIs that you run. So here it gives you something kind of like the wiring diagram, but or the wiring panel.
Connector panel.
Connector panel. Usually the connector panel, but it splits it between 2 nodes, the asynchronous call and the wait to return. So you can write all your code, you can basically spawn off 15 sub-VIs, they can go do their things in parallel, and then you can collect the data back from them as they finish, not necessarily in the same order that you launched them in. Yes?
So as far as the run VI method goes,
Top one?
run VI.
Right.
Yeah.
Run VI.
The invoke.
So what option, that's really confusing, what
The reentrant option here?
Yeah, what that,
Oh, you're talking about-
better you have to wire to open. So if I run this VI, right, and it has its own loop and it's going its merry way, I
Yes.
talk to it asynchronously, right? The caller exits,
Yes.
then LabVIEW doesn't handle that.
Correct.
Up to 2015 it did.
Correct.
So I suspect that some of those options bits I didn't set correctly.
Right, so the things you want to deal with there, you have the wait until done, which that's pretty straightforward.
Yeah.
The other one is the auto dispose reference.
Yeah,
So,
that's normal still.
Yes.
I exit the caller, LabVIEW hangs and or
Correct.
goes into this tight loop or
It-
whatever.
it's not that it's hanging, it's something is still running. When you say you exited it, are you talking about executable?
No, not even within
Development.
development. The
Ah.
caller that actually called this run the VI, right?
Yes.
Which is, according to what they write about this method,
Mhm.
it's supposed to be totally independent. I should be able to exit it, and that VI, that this one called, should be still running. And if I'm in development, I should be still be able to, bring up front panel, whatever. Something is not happening.
So, a lot of that has to do with who owns the references to other VIs.
Yes.
When you're in development mode, there's a lot of things sharing those references. So if you have your project open and you spawn something off and then you close the code that ran it, it's still running in the background off to the side. You can open up the project under Dependencies and there's a VIs in memory, and so any extra.
Cover the case, say I have an error in the caller, right?
Yes.
It stops, whatever, right? Whatever VIs it ran, using that run VI,
Yes.
they should still be fine, but
Sometimes.
it's not. Like LabVIEW kind of freezes.
Correct. So if you have an issue where you have to stop a VI in LabVIEW, it doesn't necessarily translate to the other ones, but it could. And that all has to do with how they're
Those-
organized.
Well,
those
so our
ones that I
main thing is
called,
outline.
they're not really independent. They still dependent on if this
Yes.
one, caller one.
In your last example, you show that you have to put the correct front panel, whatever that thing is called, into the OpenVI reference.
Correct.
If you make the static VI strictly type static VI, right-click, say strictly type, then you can wire that wire into the top. It will automatically do it for you. The one drawback is the very nice property that you have their VI path will get ugly. It will get large. It will say something like type 5. You know, it just gets wider, and it looks sort of weird. But you can ignore that because this is such a nice trick to not have to worry. Because then you, perish forbid, you change the static VI, you add another reference, it just happens.
Thank you very much. Yes.
This last version is certainly more readable, more intuitive,
Yes.
and more obvious. And it is used Why? Because for some reason, LabVIEW registers such processes as run, not running at top level. You cannot identify which process is ended and which process is still running.
Correct.
If you are your software runs perfectly, it doesn't matter, of course. But if it runs perfectly, block diagram doesn't matter too. So almost every time when I say, okay, this is better, this is more readable, more easy to create. Every time I say, okay, I cannot do it, I have to go with more traditional VI server as
Right, and that's one of the things we want to show, is that there's multiple ways to do it. Don't just pick one and stick with it. Try to understand the others. You don't have to use all of them, but the understanding will help you in future troubleshooting. Yeah?
So, just a couple of notes that asynchronous VIX is great for VI finishes, but like in the example above it, you do the programmatic call and then you use that invoke node to control value get. That's
Yeah.
not going to wait until the VI finishes. That will
Correct.
get your values.
This is control val set.
Yes, that's just initializing the values. It's not actually getting anything from the VI.
Right.
in that one.
The first two examples are basically call and forget, like launch it, go do your thing. The last one is because it makes it easier to get the data back and costing that extra part. They're not exactly equivalent. But yes, good call.
Another thing that I did was I tried to use this bottom example there with the strict type depths. With I had multiple VIs that I wanted to use that were the same connector pane essentially.
Right.
But strict type depth is specific to the exact VI that you're using.
It's not specific to the exact VI, but if you have something that's just slightly off on the connector pane, like the difference between a double or a single, or an enum, or a very similar enum, that will break it. Like, if you...
One question about your book diagram. You launch last version, you launch 4 rows, as you say, yeah. Which are the connections?
The last one?
The last one.
So the last one, you're actually calling an instance of that VI. So this is closing the generic VI that you're launching. It's not closing the individual ones. They've already ended.
No, I asked not about closing, about connecting.
So you want to know like the order that they come out on the array right here.
Yeah, so the order will be whatever order they finish. So you should put in something like, you're number 1, when you come back, tell me you're number 1. So if you launch 1, 2, 3, 4, it could finish 2, 3, 1, 4. So you want to make sure that you know which one's coming back, and don't just do what I do.
I just wanted to say, I got around that strict type depth restriction I was referring to by making one of the connections that was different, a variant. So that way, multiple VIs can use the same string type depth.
Yes, variant's one option, string that's filled with XML or JSON is another one. Don't try to parse strings on your own, that's annoying and time consuming. Okay, next one. So a lot of stuff we do, you might want to have either multiple users working on different things at the same time. You might want to have multiple users working on the same thing, different portions of the same project at the same time. And then subpanels make it really easy to like just sort of toss everything together. Subpanels also make it easy to be like, well, I have this one VI that controls this one thing, and now we have 10 of those things. So subpanels also makes it easy to take that one VI and say, I want to do this 10 times. So I'll go into a quick code example.
Yeah, while he's pulling that up. So for group development, it's great because we have, when we're doing a team development, we'll have one person will do the main VI, and then we can just assign out single VIs, tell them the size of the front panel that they have to put into a subpanel, and they can develop that entirely independent. And then when you have your source control or anything that way, it's really easy to bring it all together in the end. So we use that really successfully.
How do you find that the per panel updates works with subpanels?
Awesome.
But you don't have to manage it at the, like if each one of those guys.
You manage
wanted
at
to
the
tell
top level.
Right, so,
Yeah.
I mean, because I typically do it with like a count, where you count up, like anybody that wants to maybe like put that in a functional global, and when the count reaches 0, you update the functional global. Like, you update
Yeah.
the function.
Yeah.
You see that issue also happening?
So defer panel updates is specifically to the front panel. So if you have some sub-VI running in the background, your front panel defer panel updates won't mess with that one because that's somewhere else. So what we typically do is we'll just defer panel updates on the very front panel and then populate all the subpanels and then say, okay, now you can see all of them. So here, if I say I want to see 8 things, we'll populate all 8. If you change it to 2, we'll populate 2 if not running. So you want to specifically take the highest one that the user is looking at because that's the one that matters. Okay.
Yeah, one other thing while we're on defer panel updates, whenever you're unsetting defer panel updates, make sure you clear the error before that, because if you have an error going into it, then your whole front panel is frozen, and then you're what's going wrong, if nothing's moving. So always clear the error before you unset defer panel updates.
And also make sure that you stop the running VIs after you take them out of the front panel, or after you take them out of the subpanel, because otherwise they'll just keep running in the background, and then you'll have to figure out what the hell's happening and kill them later.
Okay, Quickdraw.
Small question.
Yep.
Do you know about something about some limitations in number of front panel?
Subpanels?
Somebody said me it's after some number it makes problem. I did this 40, 50 without problem, but maybe the other.
I think, well, so I know
I don't think
with
we know
like
that.
with structures, it's like 256 if you nest inside each other causes problems, but if you're doing things with that many subpanels or nested structures, you should probably reevaluate your code writing and come up with a new architecture.
We'll talk about some of that later. Okay.
Okay, quick drop. So I know Darren has given some examples of quick drop in his presentations of improving efficiency and how you program. So if you haven't heard of it, it's a great tool to make things a lot faster. So I'll just give a quick overview of it. To bring it up, control space, you guys probably already know that. You can create shortcuts both on the block diagram and on the front panel. There's a whole list of NI recommended ones right here. Learn those, we do that. You can create your own, but this is one that's been developed by a lot of people are using of the most common functions. So I would start there. The other piece that's really convenient is the macros, or they call them the control key shortcuts. I think there's 6 of them that release with LabVIEW standard. And usually Darren passes out a little mouse pad that has all of them on there. Those are very convenient to use, so learn what those ones are or create a list or something. Alternatively, you can create your own. This is a link right here. If you come up with something that would be super helpful as a control key shortcut, you can go there. There's a whole community of people who are developing all kinds of things. All you really have to do to create your own is you just drop what you just need to get the connector pane and just grab an example and just modify it there, and then drop it into this folder right here in your LabVIEW data folder. Quickdraw plugins, you may have to create that folder to do it, and then that'll automatically load the next time you run LabVIEW. So to give you an example of a Quickdraw plugin, you're going to jump over to the PowerPoint.
I think it refreshes next time you launch.
I know it used to be when you had to reload LabVIEW, because it was loaded, but they may have changed it. So
I think I've done it where I think one had it, and then I usually have to restart LabVIEw because I'm like, so.
Okay, give that a try.
yeah. Okay, so it is. So one example of a macro that we use, I don't know if any of you guys have seen this VI property window right here, and just love it because it gives you so much flexibility in doing things. So we decided that we hated it, and it's terrible because trying to write documentation is awful. So instead of waiting for NI to fix it, which has been on the ID Exchange forever, for that, we decided to write a tool that will help us document things. So we'll give you an example of this. And so we use it, we call it the auto documentation tool. It's also included in the code that you can do. So here's a super simple VI that adds 2 numbers together. You probably would never create this VI. But we used the bookmark manager here to use, again, our hashtag support. And so we created very specific hashtags for description and then inputs and outputs. And so we use those hashtags basically as you see here. And so if you look over it, there's no documentation on this VI. So if you go ahead and push Control Space, and so real quick, and so he pressed Control O, and now all of a sudden he's got all the documentation that's on your block diagram is populated in your VI properties.
Wait a minute. You just did Control Space by itself.
Control Space and then Control O calls your control key shortcut.
I didn't hear that thing.
Yes. So go ahead and pull up Quickdraw again.
Does it remove them from block diagram?
It does not. It keeps them there, and we actually like that feature because that way when you're developing the code, it's really easy to see what you're doing. And so it provides a good way of documentation of your code that when you go in and update that VI, you have the code right there and you can update the documentation.
Can you use something instead of bookmark manager?
So we looked at that at one point of trying to use the arrows that point to different things, and LabVIEW or NI doesn't expose that out to the end users, so we use the bookmarks as kind of a way around that.
The problem is that if you use such things in every VI, and you have several thousand VIs in your project, bookmark manager is not useful anymore.
So,
Actually,
if you have them all in Bookmark Manager, yes, it could become a large one. But you can also, so there's a few different ways to get around that. You can either group them by the bookmark, and then you can just collapse them, and then for these ones, it would be 3 lines, and you can just ignore them very quickly. The other alternative is you can actually create custom bookmark managers that would exclude these automatically. So that would be a way to get rid of them as well.
So here you can see you can just collapse each one of them. So if you're like, I know those 4 are found everywhere, just minimize those and then look at the rest.
Right. So you can pull up Quickdraw, and we'll just show you where the macros are. So if you click this configure button right here, it gives you information. So as you can see on here, we don't have the front panel block diagram. Those are where you can put the shortcuts. We don't have them in here because this is a fresh install of LabVIEW. But then the control key shortcuts, it has all the ones that are released by NI, and then it has our auto documentation one in there. You can change the shortcut key if you want. And there's a lot of information at that link if you want to learn more, or if you have questions, you can ask me about it. But for us, this has been a huge game changer in helping us document things better and not have to use that terrible VI that NI gives us, or modal window that is awful. So,
Yeah, worst part of modal window is it pops open, and then you're like, okay, oh shit, I forgot what I said in my code, and you can't move anything around in your code. So close it, go back, change it.
yeah, so feel free to use this one. If there's another way that you think is better, create that tool, look online, there may be better things, but find something that works for you. This works really well for us. Yeah.
Does it support text attributes such as bold?
Yeah,
It does. Mhm.
yeah, and it was actually showing it to both parts. But-
Yeah, so you probably can't really see the bold because it's just the X and the Y, and the X plus Y is bold, but yes, the names of the inputs and outputs
Yeah.
are bold.
Use HTML hash
Yeah,
slash.
But not all of them, some of them.
some of them, a
That's
subset.
why italic and.
Yeah.
Yeah.
The basic.
All right, a couple more topics left.
Okay, so I'm sure everybody loves the default LabVIEW icon and uses it on everything because it's so awesome. Bottom, it's really easy to make your own icon. Like literally, just take any picture anywhere and go to one of those first three and just upload to JPEG, PNG, BMP, whatever, and it will give you a icon file that includes icons of all of the sizes that Windows uses. And then you just go in your project, you know, your build spec and say, I want to use this icon. Sorry,
So these three, the bottom three right here are icon generators, or just ask Google.
Yeah, just go to Google and say, I want to make an icon. I typically use ICO convert. There's an online one. You don't have to download anything. You just drag and drop the JPEG, whatever, it uploads it and says, here's your ICO file. Yeah.
Maybe a question, why would you want a whole bunch of different sizes for your icons?
So, in Windows, when you look in different folders and change your view, the desktop being a prime example, on a desktop your icons are big. When you're in description or detail list, it's small. Those are two different pictures. If you have a desktop and you say you want to do display scaling, so 125%, 150%, those are each different files. So if you made your own custom icon file, and it's one file that contains all the different sizes, but you can create your own custom icon file that only contains one size. So if you're in LabVIEW, the little icon editor for your sub-VI, that is one size. You cannot then take that and scale it bigger or smaller if you made it into an icon file and went that route. So these people put together nice little tools where you just say, I have this really nice picture, high resolution, and it will generate everything from, I want to say it's like 16 by 16 to 256 by 256, and you just give it that stuff. Windows will figure out which version it needs for your desktop, for your file, or whatever, and just show you the right resolution. The last one on the bottom is the Noun project. So they have tons of icons of this sort of like simplistic nature. So these are really nice because they scale well. There's not a lot of detail. And some are available for free, and some of them are kind of free if you want to hide the registration stuff. Edit a file. And then if you want to go more advanced specific LabVIEW stuff, go to labview-button.com. So they will give you an executable that you can go take any picture from the web, drop it in, and say, I want to make a custom control in LabVIEW. And they'll give you options to be like, I want this color to change when I push the button, or I want the text to get bold or smaller or whatever. So again, you could sit there and manually modify each control to look, to your specifications, or you can just grab the program and be like, this picture, make it bold when I click on it, create my control. And that takes us to custom picture controls. So has anybody here dealt with custom picture controls? Yeah, impressive. So with custom picture controls, you can make it look however you want. So like the example, you could have 50 subpanels, each subpanel shows a couple different indicators, etc., and it gets really complicated. This also gets really complicated, but you're in control of drawing each individual thing. So I think this project started out as I was abusing a graph. I was pumping in like, I don't know, let's say 300 different like lines and plots on the graph and trying to get it to update faster. I was optimizing the shit out of it, and then finally I was like, wait, I know exactly what I want. I'm just going to make that. So picture control gives you a lot of basic functions. It's all math, so you need to know basic algebra. And then you just sort of say, I want 36 something, take the width, divide by 36, those are your points, draw a line on each one. This was specifically an application where we wanted to show 36 individual gas cells that were set up. Each one had to get up to its own specified pressure within 2%. And it was really hard for the operator to look at 36 numbers and another 36 numbers and trying to see if they were close enough before giving the go-ahead. So this, they changed green, yellow, red, depending on if it's good or not. And they can quickly look at it and be like, yeah, we're good.
Hello.
Yeah, so this is much more powerful when you actually see it rather than just a picture. So we'll show you our demo here. Again, the code is available if you go to the link we showed you at the end.
Okay, so
It's not there. Yeah.
it's correct.
Yes. Yeah, so you set up the initial background stuff, and then everything on top of it, it's redrawn in the picture. Yes.
Yeah, so basically you can see the outline, that's the picture control. Every little thing on that picture, I told it what to do. Which
So is the background transparent? Assume to be transparent on the picture control itself?
the background is whatever color you colored it. It could be transparent, but
Put
I colored it
transparent so
light.
you can put some static background.
Yeah.
Right, so in this case, first I drew the background, and then I saved off what the background was, and then I drew everything over it. But because everything could change every 10 times a second, I basically am like, okay, wipe it, put the background, draw everything, wipe it, background, draw everything. So, as you can see, there's not much control going on here. The whole idea was like, here's a simple status display, everything should be automated. But if you do have a problem, you can even interact with things, such as like when I click it, you can pop up a little window, you can lock it. It'll give you information about pressure sensors, regulator control, you can set stuff, basically interact with that particular subsystem, and you can pull up multiples. And
So depending on coordinates, all you can mouse.
yep, everything's coordinates. Eventually you'll get sick of it, but it makes a pretty nice interface. It's very intuitive to look at and see what's going on because you know exactly what you want it to do, and it does that. Yeah, it's running right now.
Yeah, we don't have any simulated data that's updating, but if you look at the actual one that we're running in the field, these little pink lines are moving, just slightly all the time.
Yeah, I think I changed it so it's not bouncing around all the time because it was freaking me out. I was like, no, the system's broken. Oh wait, no, there's demo. Yeah. But yeah, so time to go there.
Yeah, let's just jump into the other one and all. If you have questions about that, we can go back to that.
Yeah, so the code's not super complicated, but there's a little bit of math involved.
And when your user wants a 37th item, you gotta redraw the whole thing?
So I think Aaron actually has it set up where you basically just type in a 36 and it's in a for loop. And so then it just finds out what because we've actually had it where we scaled it to different sizes and it'll scale automatically. So if we did add another one, it would work right away. So that would depend on how you developed it.
Yeah, so I think in this case, I knew it would never change from 36 because that's part of the limitation. But everything that's being drawn is basically a number with a for loop and stuff. Yeah.
One of the things and I do this, is I put graphs and tabular data on the same display.
Mhm.
And it's very easy to do, and you can customize it and fit a lot in a small package using that.
Yeah. Tab data? Are you talking like the tab control? Or-
No, tabular, like the.
Oh,
you know,
like a table.
You
Yeah.
can draw a table with a text,
Yes.
very easily.
Yeah. So anyway, so with picture control, sky's the limit. You can draw whatever you want. You just have to spend the time to figure out exactly what it is you want. Graph's nice because you can just like throw in data and be like, I want a graph, and then figure out what you want later.
And it doesn't look like LabVIEW. It's very customized and people like that.
Yeah, also big selling point.
Okay, so our last topic, and apparently doesn't want to give you the name because, I don't know, NI wants to hide it or something. But, so the topic is VI
That's
scripting.
not good.
And this is,
That's
so,
a projector.
VI scripting, just to kind of open that wormhole a little bit, if you guys haven't used it, so there's very specific cases where it's great. Essentially what VI scripting is using LabVIEW to write LabVIEW. A few caveats is you don't want to rely on it on any kind of released application because NI doesn't guarantee it. They may change the functions on you, things may change. So it's a great starting point if you're trying to create a VI or do something where you're doing automatically. The example that we used it for is we had a legacy control system that had a whole bunch of manual controls on screens that looked like this here, which you probably recognize that from the dynamic event registration example earlier. So created using LabVIEW scripting because we're lazy, we don't want to put that many controls and make it work. So we basically had a big file that was all just text files that was used to, in our old program, to write up screens that looked like that. So rather than creating 60 of these screens, I'm like, I'm just going to do that in VI scripting because that's a lot more interesting than me creating a bunch of buttons and manually changing everything about them and all that. I would not want to do my job anymore. So I decided just to create a script. The one thing that you want to do when you're doing a script, you can wire things, you can add new objects, you can really do everything you want in scripting. What I found is if you're wiring things, that takes a lot of work and it's much faster just to wire it yourself. Like you guys all know how to wire two things together and you can do that very quickly. If you try and do it in scripting, it's not quick. So unless you need that, like that flexibility, it's better to just start with a template. So here's a template that I just started with. So as you can see, it will run. It uses our stack architecture on everything. Again, we have well-defined names of our controls that we have with everything. Right now, I just have one Boolean example just so it has something on there. Random constant, random number, everything is set up for there. So I'm going to start with this because I already wrote that. I can write it really quickly just using LabVIEW myself. And so I'm going to start with that template. And then I'm going to populate all the controls on there. So as you can see from here, I have a CSV file that has all the data that I want and I want to use. So things from labels, captions, data types, mins, max, Boolean text, etc. And so I just created a CSV file in this case. When we actually did it for our legacy control system, it was another defined type. So I just wrote the parser basically to look at that type and convert it into things that I wanted in that. And then, so we'll go ahead and delete these. So you can see this VI folder has nothing in it. And the VI scripting template is just a VI right there that I'm going to use. I'm going to duplicate that. So I have a script. Aaron just ran it. It took 5 seconds. And now I have 2 new VIs here. We open those up. They have everything that was on the control in there. I put random constant, put a random number in there. You can adjust values of controls, constants, various things very easily. So it's great if you're starting out, you're converting old code, things like that. It can save you a ton of time. It also takes a ton of time to write. So that's why it's kind of a wormhole if you jump into it. But there definitely are use cases if you're converting something over is kind of the main one that we've seen. There's probably other ones that other people you guys have used, but that's a good one.
I had a not dissimilar application I had an Excel spreadsheet that had lots of columns, and I wanted to be able to read and write it nicely and pass it around. I used scripting to build a single cluster. Each element of the cluster was one of those named things, voltage 1, and the type was whatever it deduced the correct type was. Usually integer or Boolean or string. And it was a fairly easy script to write. I ran it once and I had my cluster. And when somebody came to me and said, oh, we have to add 3 columns to Excel, I said, Okay, I ran my code again. I got a new type debit, broke everything, of course, because it's a different type debit.
Yeah.
But now I just go into my code and I say, where is it broken? That's why I have to add the new code. Right?
Yeah, so hopefully with, a lot of this stuff, we kind of just, went just enough to kind of whet your appetite, give you ideas of what some use cases for each of these different things are. This is definitely not meant to give you all the information, it's kind of give you a few more resources of where to look, what scenarios work really well for these different things. So if you have questions, want to talk about anything else, then...
Yeah, the original intent of this presentation was to try to get our user group thinking more along the lines of what kind of things in LabVIEW help me, and try to get those things out there, share it with other people, like we saw, get some feedback, be like, oh, hey, there's an even easier way than what you did. So, yeah.
URL.
Now you So yeah, and if anybody has any feedback, feel free to email us. We have business cards and stuff, or our email addresses are online. We are more than interested in finding easier ways to do our job, because we appreciate slacking off after we're done. It's very important.